Hello and welcome to Forward. Our guest today is Adam Oliner, the CEO and founder of Graft. Graft is a cloud native platform that empowers organizations to leverage the most advanced AI techniques to unlock the value of text, images, video, audio, and graphs. Before co founding Graft, Adam was a head of machine learning at Slack and director of engineering at Splunk. Before that, Adam co founded Kuro Labs, which commercialized battery analytics technology. He earned a Ph.D. in computer science from Stanford University and a Master of Engineering from MIT. In this episode, we talk about what is modern AI and how Graft empowers organizations to build AI systems in a way it is done by the top technology companies, cutting the time to value from months to days or even minutes. We also talk about what to look for in your future co-founders, why failing is an essential part of entrepreneurship, and how generative AI will change the way we treat video content on the internet. Adam, welcome to the show.
Thanks, Adam. Great to be here.
Let's start by talking about the challenges organizations experience with building AI systems today.
Certainly. So, some organizations just face the talent and infrastructure barriers. And so they have trouble even getting started. I don't know when the last time you tried to hire a machine learning engineer is, but they're fairly expensive and are sort of being hoarded by these top AI companies. And if you want production AI infrastructure, you need to have some number of these ML engineers in order to build and maintain it. And so often that's a sufficient barrier for organizations to even get started. Some do get started. They get sort of lured in by the sexy demos that a lot of these AI companies provide, and then discover that in reality, a production AI system is a lot more than a model and something to serve predictions from it. So, we can talk about orchestration or observability or debuggability. We could talk about security and end-to-end performance and reliability or compliance or any number of these other topics that even if you're doing ML at a reasonable scale, you still should care about for production use cases. And so they get really excited about the model or the predictions that it serves, and then realize that actually it's a huge investment to put those into production and be able to have confidence that they'll continue to do the right thing or not do the wrong thing. And then there are some organizations that will overcome those two barriers and will spend years and millions of dollars going down the homegrown AI infrastructure route, only to find that they have trouble getting models into production. Like you see statistics ranging from like 70 to 90% of models don't actually make it to production. A lot of these tools and infrastructure will lack basic usability. Like it was designed by infrastructure engineers. And so when someone from the product organization or business BI analysts or what have you try to use the product, they realize it wasn't designed with them in mind. And in general, just tend to be more fragile and inflexible because they were built by ML engineering teams, which almost universally are understaffed. And so they scope it down to whatever the organization can afford, even if they're a fairly mature, large technical organization, and then often end up with something that sort of satisfies the immediate use cases, but doesn't have any sort of forward-looking capability in terms of being ready for new ML improvements.
People who work in this field talk about 80% of efforts going into building infrastructure and only 20% going into actually doing productive work and building the productive models. And then it takes months to get there to productive models. And as you said, 80% or something, vast majority of those models never even reach production. So that's a really grim picture. Is it the picture across the board? There are some bright spots.
I wouldn't say that I describe these as sort of dark spots necessarily. I think the point is just that doing this for real in production is hard and requires sort of time and money if you go this homegrown route. I think what we're trying to do at Graft is remove all of the dark spots, if you will, so like the painful parts. Sometimes we'll talk about Graft as sort of freeing you from doing this infrastructural plumbing so that you can focus on the data and the use case and the sort of fun modeling stuff that sits in between. instead of having to worry about, oh, how do I propagate this data deletion request to handle a GDPR request or what have you. Those are sort of not the things that you want these organizations to focus on. So I think, I think partly the bright spot is that Graft is trying to build a path for these organizations that is an alternative to these other ones that I've described, where you have to hire an expensive team, spend years building this infrastructure internally, and then maintaining it forever. We are trying to be an alternative to that entirely, where you don't need any ML engineers. If you have them, great, they can focus on the cool stuff. But that those barriers kind of go away. So I'm certainly excited about that.
I am as well. The green picture that I painted is, to me, a picture in transition. It's that way right now, and it is that way with every new technology. With every new technology, you have to build tooling yourself initially before you have the tools from the companies like Graft to speed things up and relieve you from that burden.
Yeah, I think you're right. Describing it as kind of an industry in transition, I think is spot on. And you can kind of look back at other industries that have undergone this sort of maturity curve where, initially there's like some company that does it for the first time and everyone gets really excited about it. So like you could even go back to like the car industry or something, the first car is like the Model T or what have you, right? Like you look at pictures of them now and you think like, I could probably build that, right? Like I can go buy the parts and I could assemble a Model T. And there was sort of this long period in between where car companies were making cars, but a lot of folks would still, get under the hood and fix things or change things to customize it. But now it's reached this level of maturity where, like, if you are, a race car team, the last thing you're going to do is build your own car from scratch. You're going to work with some well-established car manufacturer to go do it. Because even if you do a bunch of aftermarket stuff, 99% of that car is going to be made by an organization that knows how to build cars, and that is what they do as a specialty. There is no such organization for AI infrastructure yet, and Graft is trying to be that. And so what you see is now a bunch of hobbyists who are getting a bunch of pieces from 20 different vendors for all of the different things that they need, open source tools and so on, and like building their own bespoke AI car. And then they have to maintain it forever. So if it breaks, there's no one they can call. It's kind of it's a project, and it's maybe a feather in your engineering cap, but is probably not the best way to spend your time. Because for almost none of these organizations is that AI infrastructure the competitive differentiator. It's usually the data or the use cases. And all of that investment in infra is just a means to an end. And if you can shortcut that with something like Graft, just buy a car, we think that's just a way smarter way of getting to AI maturity.
It's definitely not the way to spend 80% of your resources, limited resources, and very expensive resources.
Yeah.
Now, there are multiple ways of addressing these challenges in the market, early stages of the companies that are building something there. But Graft is taking it, I think, from a little bit different perspective. And you call this perspective modern AI. So talk about it. What is modern AI and what is Graft approach to address these challenges?
So modern AI is an approach to doing AI that all of the top AI companies are converging around for basically all of their use cases, including search, recommendations, content moderation, personalization, customer analytics, market analysis, et cetera, et cetera. They're sort of using it for everything. And Graft has distilled that infrastructure to its essence and packaged it to remove these skill and infrastructural prerequisites. And so with this modern AI approach, you can build AI solutions and deploy them to production in minutes, even if you have zero ML engineers or infrastructure. So what is actually the technology under modern AI? A few of the sort of core technologies are these pre-trained models or foundation models, trunk models, depending on who you are, you call them different things. I may call them trunk models mostly. But think of like BERT or GPT-3 or others, and there's a proliferation of them. Currently, for a relatively small number of data modalities, only just now do you have a few multimodal models, but you're going to see more and more of those being built by an ever-growing list of companies who are just improving and growing these foundation models. And the way that modern AI works is it leverages those models to compute representations of the underlying data in the form of something called embeddings. And then you largely use those embeddings as the representation of that data moving forward. So embeddings have some really nice properties. One of them is that semantically similar things end up near each other in the embedding space. So if you have some piece of data that you have the embedding for, you can just look for nearest neighbors in that space and you kind of get things that are semantically close to it. And similarly, you can, if you want to train any sort of downstream task specific model, you just do that from the embedding rather than from the raw data. And there are a bunch of advantages to this, including greater efficiency of model training. So if an image has 1 million pixels with 3 color channels, that's 3 million numbers. And so if you're trying to learn in that space compared with like a 500 dimension embedding, you have many orders of magnitude larger space to learn over. And what's kind of magical about embeddings is that they kind of encode all of the important semantic information for a huge swath of use cases, many of which I've listed out. And so essentially, this is what that modern AI flow looks like. If you want to predict something like customer churn, you would take all of the multimodal data related to customers, you would compute these embeddings and some representation for a customer, and you would learn a churn predictor or something like that from that representation, which is much more compact and efficient. And there's a whole ecosystem of tooling and methodologies that surround this. So for instance, you may want to customize that foundation model to your data or use case. And so people will do additional model pre-training on those trunk models. You may want to improve the labels that you're training those downstream models on using tools like active learning, many of which rely on embeddings as the underlying representation. And Graft is taking sort of all of that workflow and all of those capabilities and packaging it up in what we think is a really nice, easy to use UI. And that modern AI approach is, again, kind of what these companies are using to the exclusion of basically everything else for production. You could certainly find data scientists who are like building XGBoost models on their laptop and things like this. But for what is happening at scale in production, modern AI is sort of the way that they're doing it. This is not largely disseminated. Like there are very few companies who are really leveraging those technologies to their full extent in production. I mean, you could probably count them on 2 hands, maybe not 1, maybe 2, but it's still a vanishingly small number, effectively 0 if you look at the entire economy.
Most of the other MLOps approaches work with the previous iteration of AI before modern AI became the norm for those organizations, while you skipping that step and going right to work with the structure of modern AI.
Yeah, I think that's largely right. Some of the hallmarks of modern AI are that it's data centric as opposed to like model centric or parameter centric. So I think if you were building a classical ML platform, you would build in all sorts of knobs and mechanisms for doing feature engineering and hyperparameter tuning and model selection and all these other things that are essentially totally unnecessary in a data-centric AI perspective. And certainly modern AI is an example of that. And so that's a huge number of knobs and machinery that you just don't have to build or expose to users. And I think in addition to that being a much easier system to build, it also makes it much more usable because there are personas for whom if you say the word hyperparameter, you've lost them because they're like, I want to know if customers on social media seem to like this new product that we launched. I do not care the depth of this network that you're building or some other nonsense. And modern AI is exciting because it abstracts a lot of that away and shifts the focus to the data and the use case, which is, I think, where ultimately everyone should be interested in being anyway. Again, the AI machinery was just a means to an end. And so, yeah, you're right. Like if you look at classical ML platforms, there are a ton of knobs and settings and things that you like need to fiddle with in order to get things to work. And they're starting to dip their toes into unstructured data, but it's really like an aftermarket add-on. They're sort of shoehorning that type of data into a platform that was not designed to do modern AI.
The whole idea of taking infrastructure and approaches from organizations like Google and Meta and making it available for broader scope of organizations does sound exciting. What kind of organizations do you see as the best fit for Graft, and what roles within those organizations?
Generally, there are 2 kinds of organizations that we target. There are those that want modern AI infrastructure. And then there are those that don't care about that infrastructure, but they have use cases that they want to solve. So for those that want the infrastructure, Graft appeals to at least three different personas within the org. At the executive level, you just get much faster time to value. So you don't have to wait 9 to 12 months to build out this infrastructure before even trying some new use case. So, you can often build and deploy something in Graft and like get a baseline for performance in a few minutes or hours. So the time scale is completely different. So that's great from an executive perspective. At the sort of eng leadership level, they get to do more with the team that they have because no one needs to be building and maintaining all of this AI infrastructure, all of that plumbing. And then at the ML engineering level, they like it because they get to focus on the fun, sexy parts of AI instead of the plumbing. So that's the sort of infrastructure organizations, as I'll call them. But then there are those that are, I think, far more numerous, which are just looking to solve some number of use cases. I think, broadly speaking, every organization has more than one use for their data, but they usually start with a particular use case and say, this is what I want to solve this one with AI as a starting point. And compared with point solutions that you might find for just solving a single use case, there are a few advantages for Graft. One of them is the flexibility and customization. So a lot of those third-party point solutions, they have some proprietary model, living behind their API, and you feed it data and it gives you predictions. And if you don't like what it's doing, then you have to find another vendor. That's sort of the end of the interaction. But in Graft, you have these additional pre-training capabilities, and I use the technical term for it, but you just say you push a button and it will, whatever data it's wired up to, it will learn based on that data. So it's like usability wise, you don't need to care about the pre-training. Or you can enter one of these labeling or active learning flows to iterate until it is not just sort of better performance, but is also kind of customized to your own particular notion of what that predictor ought to be doing. So, you might be doing content moderation, and your notion of what constitutes toxic content may differ slightly from what some third-party vendor's notion is. And you can enter one of these labeling flows and customize it. Graft is often lower cost than those point solution vendors by virtue of the fact that those vendors need to make all of their money on that one use case. But Graft's perspective is that we will be the intelligence platform for all of your data and use cases. And so, we view it as a kind of long-term relationship with our customers where they may start with one use case, but they'll find that really easy to deploy. And so they'll start on the next use case and then the next one and so on. And that's the last sort of benefit for going with Graft as far as these like point solution vendors is that you don't have only one use case for your data, you have many. So either you're going to end up with 20 different vendors for all of these different use cases, or you've worked with Graft.
For the business users, this ability to empower them to do things with machine learning sounds like a very interesting opportunity. I wonder what kind of complexity do you expect there? I can think of my moments of discovering something like a pivot table in Microsoft Excel. That's extremely simple thing, quite powerful. On the other side of complexity scale, I would think about maybe being able to write my own SQL query to pull some data from the tables. Also, very powerful thing. Takes a little bit more training, but then you have a library of your queries you wrote before, so you can just adjust those things a bit. Still possible for a business user, though a little bit more tricky. So, what kind of benchmark for yourselves do you have when thinking about that UI for Graft? Where should it be? Close to pivot table, close to SQL query, or something else?
So I can answer this in the sort of short term or the medium term. I think in the short term, easier than writing SQL, I think is where we're targeting. So there is a SQL interface in the product. So if you want to write SQL with some moderate extensions to support some of this sort of similarity search and things like that, then you can absolutely do that. But we do have a query builder as well, where you can just click through and describe the use case, and it will generate the SQL for you. So you can write SQL, but there is also an easier interface for generating that. And that's just one of the ways that you can interact with the data. So there's a UI. A lot of this can simply be visually exploring or orally exploring, if it's audio data or video data, for instance. just via the UI. There are APIs if you are more the type of person who wants to like run curl or something like that to consume data in that sort of form. And then there's an alerting framework. And so you can wire up automation such that you don't necessarily need to be, working inside of Graft per se on a day-to-day basis. It's more like I'll get an email when a particular prediction is made and be able to act on that outside of the tool. So we certainly are trying to make it something where you don't have to be writing code in order to leverage the capabilities. Maybe sort of in that context, it would be helpful to just walk through the Graft workflow to give a more holistic picture.
Yeah, let's take a look at how that workflow would look like.
Yeah. So the first step is configuring data connectors to point at your data wherever it lives. These could be cloud storage like S3, SaaS tools like Zendesk or HubSpot, or public internet like social media. Those are generally speaking the types of connectors that we have. And then you stitch together that data from those sources into conceptual buckets that we call entities. And when I say stitch together, I mean you sort of select the fields and data sources that you want to be included in one of these entities. So for example, you might build a customer entity that consists of the audio of customer support calls in S3, notes from your sales team in Salesforce, trouble tickets they've submitted in Zendesk, et cetera. And so you end up with this entity that is multimodal and time varying and kind of includes all of the information that your organization has about that entity of interest. You could do this with products or customers or employees or whatever you want. And then you can enrich those entities or the underlying data with predicted properties. So we call these enrichments. A canonical example of an enrichment is sentiment on text or churn on a customer entity, but it can be anything you want. And in fact, if you provide Graft with some examples, it'll build a custom enrichment for you. So you can just say, these 12 images are cute, these 12 images are not. I want you to enrich any incoming images with some kind of cuteness score. And that's sufficient for Graft to do all of the underlying AI for you. And then, as I mentioned, you can query these enriched entities using SQL with the help from a query builder. And that's generally for more sort of interactive queries or exploration. There are APIs for production use cases if you want to wire it up with a web front end or an app. And then there's an alerting framework if you want to take automated action. And so, yeah, we're trying to design all of this so that it's super easy to use. And that's the current form as a platform. We're also building things that we call guided flows that make it even easier to sort of hold your hand through particular use cases. So if you're trying to do something very standard like content moderation, it will walk you through that process. And in the same way that you would get onboarded to like a mobile game, put your farm there, harvest the wheat over here, et cetera. It's because those flows are not really that different from one customer to another. It's like, oh, I want to do customer analytics. It's like, okay, tell me where your customer support data is. Tell me where, what CRM you're using, et cetera. And once you've wired those up, these guided flows make it super easy to do those use cases. That's a little bit further out, but as far as the platform, we're certainly trying to make it super easy.
Those workflows should be similar. The data is different. The criteria for you to filter it or to annotate it or enrich it is different, but there is little reason for the workflow to be dramatically different. I'm curious what kind of problems can be solved with modern AI generally, and how do you guide customers to think about what is possible? Some examples like semantic search or churn prediction that you talked about versus what is not yet available, like a chatbot at the human level of versatility.
Yeah, it's a great question. Setting expectations in AI is tough because there are 100 other voices shouting stuff that's indistinguishable from nonsense about it. And certainly you've listed some of the common use cases. I guess in general, what distinguishes modern AI use cases are a couple of things. First is the kinds of data that you can use. So you can leverage unstructured text, images, audio, video, graphs, for starters. And you can combine them in arbitrary ways to build multimodal entities, which I think greatly expands the use case surface area. So if you can only work on an individual modality, or you can only work on structured data even, that's a much more restricted set of contexts in which you could solve problems. But so being able to pull in essentially sort of arbitrary data and nest it and build these entities in fairly arbitrary ways, that's a much broader use case surface area. And then the second sort of hallmark of modern AI is that you typically have drastically reduced data requirements. So I think gone are the days when you need millions of data points and tens of thousands of labeled examples to solve simple problems. For many use cases, you may not need any labeled data at all because it essentially is just a similarity search of one form or another, or it corresponds with one of these preceded enrichments that Graft includes. So often you can solve the use case, with no labeled data that's specific to you. I think in general, trying to characterize like what are good problems for modern AI, I think if you can frame the problem as some combination of finding or grouping similar things or predicting one or more properties of things, it's likely to be a good fit. That is obviously extremely broad, but this is sort of why top AI companies are converging around modern AI as the approach, is because it is, in fact, extremely versatile. Once you leverage these pre-trained models so that you're not starting from scratch, you can really quickly get to a representation that is then just a hop, skip, and a jump away from a huge swath of predictive use cases. And in combination, it just means that most of the time you may not have to do any sort of labeling or training at all. And when you do, the requirements for that are greatly reduced. And you asked a question earlier of like, how do we sort of measure success here? Two of the things that we talk a lot about internally are time to value and iteration power. So between when I articulate what my use case is and when I have a baseline in production, how long does that take? And we're aiming for that to be measured in minutes rather than months. And for iteration power, this is a combination of how much improvement should I expect to get per iteration or per additional label, some sort of function of this. We're trying to give you the most leverage for your time and for the work that you put in as possible. So it shouldn't be that you need to label 10,000 things before you get a 0.1% improvement to some metric. Hopefully it is much more powerful than that, and you can do it with way fewer iterations.
Few minutes from start to first results. It's possible when you have when Graft has one of those pre-trained models that you can apply, and then if you need to do some additional training or additional work with your data, that might take hours, but it's still not months.
That's right. Usually, I mean, some data cleaning efforts can be intractable, certainly. Like sometimes it's just a mess. But the fact is, those investments are useful for the organizations anyway, sort of independent of a specific use case. So I almost view that as like housekeeping rather than part of the blocking time to value.
You also already touched on how organizations should think about what they should build versus what they should buy as a vertical application. Can you unfold this a little bit more?
Sure. So, we try to play nicely with the rest of the ecosystem while simultaneously not assuming that any customer has any of it. For example, with data storage, Graft has this ever growing list of connectors for cloud storage, SaaS tools, public internet. And so we're trying to meet the data where it lives in its natural form. And so we're not being prescriptive about, if you want to do customer analytics, you got to use this CRM or, have to, put your data lake in the following format or anything like that. If you have existing AI infrastructure, then Graft provides ways of interacting with those other tools. So for example, if you wanted to use Graft like a glorified feature store, then you can do that. You can configure these data sources and build your entities, and implicitly you're sort of getting these sort of embedded representations of those entities. You can enrich them as well, and then use an API to just grab those features out of Graft and trust that Graft's data pipelines are going to keep those entities up to date, and you'll sort of always have a current representation of that entity. And so then you could consume it in some other tool for building a different kind of model if you wanted to. And there are similar APIs kind of around the product for consuming those intermediate artifacts. We also allow bespoke foundation models. So if you're sort of on the high end of the sophistication spectrum and you're building or customizing foundation models for your own internal use cases, then you can put those into Graft and use that as your trunk model if you want to. And so we try to make it easy to continue to use whatever you're currently using. And in fact, part of the name of the company comes from the fact that we intend for the sort of deployment and quote unquote integration process to not be a rip and replace that you can kind of graft onto the side of anything you currently have, solve a use case end to end, and maybe you're pulling things out of the middle, but you're grafted onto the side, and now you can kind of solve your use cases. And if you happen to have other things that you would like to interact with, then we certainly allow that. But you shouldn't need those other pieces in order to solve the problem. And that's kind of the dance that we're doing. This graph should be sufficient, and it should not be exclusionary.
And it should be applied modularly to the specific parts of the stack that currently makes sense for you. What's your approach to data quality overall? It's another major bottleneck, and people also call it an 80% issue for data scientists this time, who spend a lot of time on cleaning and preparing data and only 20% to do productive work.
Yeah, I think, and I said this a little bit earlier, that I think an organization's data is a strategic resource. So any investments they make to clean it or organize it, that usually pays dividends, short and long term. So I think that's a worthwhile investment, sort of orthogonal to any particular AI directions or use cases. I think data quality is also an extremely broad topic. We certainly don't offer a magic bullet for it, but there are aspects of Graph's design that mitigate those issues to an extent. So, for example, we connect directly to SaaS tools and social media and other things that have kind of well-structured APIs for pulling out the data. So in those contexts, we can expect that Graft is getting a fairly reliable structure, at least, for the data coming out of those tools. And that doesn't mean that tweets that you pull off of the Twitter API are going to be like well formatted or structured or anything like that. But we know that that chunk of data is the tweet text. And then the second thing is that then you pass that potentially still dirty, unstructured data into one of these foundation models. And in general, those are just more tolerant to dirty data than some of these classical methods. Again, not a magic bullet, but it's not like the pipeline is going to explode because they used a word that was spelled slightly differently than what the tree was expecting or something like that. So that the fragility of classical ML is sort of gone from that. So it's more tolerant to certain kinds of data dirtiness, at least. And then there's another kind of data to talk about, which are labels. So mostly I've been talking about, I think, about the raw data or the input data. But then there's labels, and Graft has a pretty good story around that, in particular that we are building active learning functionality that will guide your labeling activities to be maximally efficient. So rather than picking 100 random examples and labeling them all and crossing your fingers, Graft uses this representation that it's built to suggest to you which are the examples that you should label next that are most likely to improve the quality of the resulting enrichment. And so in that sense, label quality is, I don't want to say a solved problem, but we're providing tools that I think are going to be the best way to improve labels for your use case. The input data quality, part of the reason that it's such a difficult thing to address is that it's not always clear what clean means absent a bunch of business context and use case context. So, you can look at, fields in a table and you see two words that look really similar. They're spelled slightly differently. Are those different values or not? And I don't think any tool can just tell you the answer to that without some kind of input from the business context. And so that's not a problem that I think any organization or any tool is going to be well positioned to solve. I think that's going to ultimately fall to an organization. But it's a good use of time.
It is a good use of time. And I do see emergence of industry-specific tools to clean data that have a little bit more insight generally into the terminology of that field, and then they can kind of differentiate if it's just misspelled or anything. We had an interview with a company doing this in healthcare, and it's a lot of things you can clean there automatically because you know the field, you know the subject. You can clean it a little bit easier. Another aspect of the modern AI systems is that as AI adoption grows, we will see more attacks on AI systems with the goals ranging from reverse engineering the model, stealing the underlying data, evasion, or outright poisoning, compromising the model's integrity. How do you see the AI threats landscape evolving? And what's your approach to AI security?
So, to some extent, certainly with adversarial AI, there are a lot of people working to address this at the level of the foundation models. So, trying to avoid these sort of point inputs that result in sort of catastrophic outputs or things like that. And I think that's a good use of time. We're sort of relying on these foundation models to address some of those specific issues. But in a sense, that's also kind of a security trap because it's focusing attention solely on that one model, where the actual surface area of a production system and a use case is much broader. Graph's perspective is thinking instead about kind of the end to end security of the system and the vulnerabilities of AI in the context of a use case. And we think that's usually a more sort of effective and efficient way of viewing security. I don't think we're unique in having this sort of holistic security kind of perspective. I think end-to-end security is usually what people ultimately care about. So from the modeling perspective, I think there are smart people working on this problem. There'll be better tooling that we'll be able to adopt inside of Graft over time. And in the meantime, we're thinking about ways to secure the resulting system or provide tools for a user to assess whether there are attacks happening at the use case side of things. Because a lot of the time, these adversarial inputs can never be generated by that production system because it's sort of not a valid input to that use case. And so spending a lot of time worrying about whether a stop sign with a sticker on it is going to cause a problem, if you control the images that are coming in, is sort of not necessarily a thing to worry about.
Right. It's more about worrying if your system that, for example, assigns risk profile to your loan applications, if it has been messed up with and now it assigns the wrong risk scores.
Yeah, so explainability is something that we care a lot about. One of the weaknesses of modern AI is that a lot of that tooling does not lend itself naturally to explainability. So if you just grab a foundation model off the shelf and compute some embeddings and then train like an MLP or some other neural network to predict a property from those embeddings, and then you ask, why did you predict that this customer was going to churn? Or why did you say that this person shouldn't get a loan? There's not naturally tooling that you get from any of those, either the foundation model or the downstream task model, the enrichment model, that will tell you why that prediction happened. And so we're building functionality in Graft. It's not in the product quite yet, but that will help facilitate those sorts of explanations. And I guess you could put that into the category of like security or at least trustworthiness or sort of the confidence that a user can have in deployed production AI. I think it's super important. And we care a lot about bias and fairness and are thinking about better ways to help users mitigate that in production.
You've been building AI systems at Slack and other companies, and now working with your design partners. What do you see organizations often misunderstand or underappreciate about building AI applications?
The model is just a tiny piece of a production AI system. There's a famous figure from a paper out of Google from several years back that showed this picture of like an AI production system. And there was like some little box in the middle that was like the ML part. And everything else was the supporting infrastructure to actually do it in production at scale, safely and reliably, et cetera. And I think organizations will often see a sexy demo of some new model doing something amazing. And they just think it's a simple matter to deploy it internally. That's really not the case. I think even if you're doing ML at a reasonable scale, as they say, as opposed to something like exascale, you still need orchestration, observability, security, testing and validation, potentially explainability, depending on the context, and so on. And I think most of that requires engineering work to build and maintain. And it's the vast majority of the work, as we've discussed, the cost of doing production AI. That is very much the most common misunderstanding, I think.
A lot of work to get the models running, a lot of work to maintain them running, a lot of work to ensure scalability and reliability in production.
And everything around the models too, right? The models require you to feed them something, and that something has to be kind of consistent in syntax and semantics and quality and things like that. And there are data pipelines that you would need to build if you didn't have a product like Graft that would help you ensure that there's no data drift or concept drift and other things. And that's at the input side. And then there's the use case side where like user behaviors might change. You need to have some observability into that sort of thing. And again, like the focus on the model, I think does a disservice to the customer ultimately trying to make this work in production.
And it will take some time for organizations to understand it. After they learn it the hard way, many of them experiencing it themselves with their first models that they built and deploy in production.
Yeah, some data scientists will say like, "Oh yeah, I saw that. It was really cool. Let me try it out." And they, bring it into a notebook and they get it to work and they go, "Yeah, this will be easy. Let's just put it into production." And then 9 months later, they're still trying to figure out how to do that because it turns out that, it's very different doing something at scale reliably than doing something in a notebook. It's really easy to do a quick demo in a notebook. I think it's not a convincing demonstration that it will work in production.
Yeah, exactly. You do a lot of novel things at Graft. Curious, what would you put Graft on a scale from pure research to pure applied AI?
So Graft is a real production system. We're definitely very focused on the practical application of AI to every organization. I'll say though, we're leveraging technologies that came out of the research community only within the last few years. And it's being built with an eye toward what we anticipate that research community will produce over the next several years, including things like multimodal models, which Graft is designed from before we wrote the first line of code to support elegantly. And so we very much care about helping our customers get business value, organizational value, mission value out of AI. And that's the goal. We may produce, novel solutions internally to how we bring this to the 99%, as we say. But our goal is not to write papers. That might be a side effect of what we do, though.
Let's talk about origins of the idea and the company. What became the trigger for you to start Graft?
So when I was at Slack as their head of machine learning, we wanted to pursue a project that we thought would have sort of maximal leverage for the company. So machine learning was a function there, but it wasn't a huge function. It wasn't like, half the engineering budget was going toward AI and ML. And so we had to prioritize what we were going to build. And so we said, like, if we're going to build just one system, one capability, what would that look like? And so we started looking around again at what these top AI companies were doing. And we talked with folks, for example, at Meta, and they said, we used to train thousands of end-to-end machine learning models, and now we basically train one for feed ranking, and for everything else, we're using this kind of modern AI infrastructure. And we talked with company like people at Amazon and Google, and we realized they were all kind of doing the same thing. And so we said, well, can we leverage pre-trained models and embeddings at Slack and deploy a similar kind of capability initially targeted at semantic search and recommendations? And right now, if you go into Slack, if you search for channels or people, you'll get semantic search results. There are recommendations around the product, like if you join a new channel, suggest other channels to join, things like that. Sorry, I'm not trying to take you on a Slack feature tour, but the
No, I
point is
love Slack. So
yeah,
it's
there's
all
like a
right.
bunch of features throughout the product that we wanted to improve or to enable in the first place. And so we did the sort of simplest thing you could imagine with this modern AI stack, which is like download a trunk model off the internet, pass Slack data through it to get embeddings, and then do things like averaging those embeddings to build representations of channels or people, or looking for nearest neighbors to do semantic search or recommendations. And we just started there to sort of see how far we could take it. And it was wildly effective. Like it was a sea change in terms of search quality, performance, and enabled a bunch of these recommendations. The only way we were able to do it is because we had the infrastructure to enable that to be sort of relatively within reach. And we had some really smart people on the team. So, looking back at sort of career accomplishments, it's always the people on my team who are doing the smart things, not me. So, when I talk about what we did at Slack, I really mean what my team did at Slack. But anyway, they built this system in the sort of the vein of modern AI, and it was really effective before doing any of the clever optimizations that you would then want to do next. So we didn't do any additional model pre-training on that foundation model. We didn't do any downstream model training. In fact, the entire use case didn't involve training any models at all, which if you come from a classical ML world and you said, oh, here's some new use case, let me build a model to solve it, you've already taken a wrong step. Right? And
Yeah.
so this told us a couple of things, right? So first of all, if you don't have to train any models, you don't have to have any labeled data, there are a huge swath of use cases for which organizations, especially smaller ones that don't have a bunch of data and certainly not labeled data, that now these use cases are in reach for them. if they had the talent and the infrastructure. But they didn't. And they don't generally. Almost no organization has the ML expertise to build modern AI infrastructure. And even fewer have any part of that infrastructural puzzle already built out. And this was sort of the genesis of saying, like, okay, well, maybe I should go start a company around this. And so the next question was kind of, can we imagine a world in which we took the modern AI infrastructure at these top AI companies and distilled it down to its essence and made it so that you don't have these skill and infrastructural prerequisites in order to use it to solve problems? And once I had the confidence that the answer was yes, and that almost every organization in the world could benefit from having access to this, pulled the trigger. Here I am.
Having first-hand experience with the problem and starting a company around that problem sounds like a great way to start a company. Much better than just thinking about a problem that may or may not exist, or just running with some new technology that nobody yet figured out how to apply, but you think it can do great things, and then you kind of look for a problem for that solution.
That's absolutely right. Yeah, but I also think it rhymes with, but is not the same as another way that you typically see AI companies sprout up, which is that a team at one of these bigger AI companies will solve some internal use case and then spin out that component as a company or as a product. And that's sort of critically different than what Graft is doing, in the sense that Graft is a complete solution rather than being a component. And I think if you come out of Uber or Google or one of these larger companies, it's really easy to think that the world looks like those companies, and it categorically does not. And so if you build one component of this system and then expect that other organizations are like, they're all set for AI infrastructure except for this one piece, which could be better, that's a very restricted set of companies. And for the modern AI stack, it's even more restricted because even fewer of them have that infrastructure built out. You can find a lot of companies that have some amount of classical ML infrastructure, but not modern AI.
The fact that you had this experience at Slack and not at those Metas and Googles gave you the opportunity to see what kind of issues will the rest of the world deal with when applying modern AI.
That's right.
And you also have a great group of co-founders who started Graft with you.
I really do.
How did this group come together?
Yeah, so I have 5 co-founders, which is more than the average. They're extraordinary. The first couple of people that I reached out to, Eric and Maria, they were both cohorts in the Stanford Ph.D. program. Eric and I were office mates there. In fact, Maria I'd known for as many years. And they're both just like extraordinary people, both in terms of technical brilliance. I mean, the Stanford PhDs in computer science and all sorts of publications and other accomplishments. But I also love and respect them as people. And having started a company before, one of the key learnings from that was how important it is to have co-founders who I admire and respect and like being with. Because you're going to spend a lot of time, if you're starting a company, you're going to spend a lot of time with your co-founders. And I think, if you just optimize for intelligence, then when things don't go well, or when you have a disagreement, or even when things are going well and they're just pulling in a different direction from you and you can't resolve it, you're going to really regret not also optimizing for personality and workability. But so anyway, so Maria joined, and then Eric, and I asked both of them, who are the best engineers you've ever worked with? I think I said best people you've ever worked with, but we were looking for ICs. And so, Eric pointed at Arena, who he had worked with as a research scientist at VMware, and Maria pointed at Mick, who's been doing software engineering for a quarter century, which is a long time in software, at many of the top software companies in the world. And then my friend, who used to be the lead recruiter, the technical recruiter at Cruise Automation, he's recruited a bunch of brilliant AI engineers over his career. And I just asked, who's the best person you've ever recruited? And that's how I ended up with Brian, who was the ML platform lead at Cruise. And, partly I feel like I just got really lucky. These co-founders are just so smart and amazing to work with and work well together as a team. And I wish I had some foolproof advice for anyone else looking to do something similar, for how to end up with this magical admixture of amazing people. But yeah, that's how we ended up with that initial founding team. And yeah, we've tried to keep the bar extremely high for hiring since then.
Yeah, that was something I wanted to ask you about. Maybe, if not advice of how to end up with such a great group of people, then how should entrepreneurs think about getting a co-founder? What kind of things they should think about before extending the invitation to someone?
So, I think all of the usual wisdom applies to hiring generally and finding a co-founder. So, no, can I swear on this? No brilliant assholes, for example.
Yeah, it's totally fine.
Yeah, this is the internet. I can curse on the internet. You want to look for team players and things like that. But I think there's a certain type of personality for early stage startups in particular. Because I think one challenge with hiring AI talent is that most of it comes from one of these very large companies where there's a ton of supporting tooling and infrastructure and so on. And when you join a startup or start a startup, none of that exists. And so you're going to have to do a bunch of take out the trash sort of work. And we don't have an office, so I take out my own trash. But I mean, metaphorically speaking, there's just a lot of like grungy, unsexy stuff that's well below their pay grade, and it has to be the type of person who's just going to go and do that. Like, hey, we got this weird tax notice from the state of Nevada. Like, someone's got to get on the phone with our payroll provider and deal with it. And if you have a co-founder who's like, oh, I was an ML scientist at such and such, like that's not my job. They're not going to make a great co-founder or a great early startup employee. And that doesn't mean that you want them to be devoting their time to those sorts of activities, but there will be a lot of that. And they have to not be like too proud to roll up their sleeves and solve problems when they need to be solved. That's hard to filter for. If you were meeting someone for the first time and you're just interviewing them, trying to suss out what this person is going to be like under stress, or whether this person is saying that they're going to roll up their sleeves, but is going to be suspiciously busy when it's time to do that. That's hard. I think one of the things that we did well with the co-founding team at Graft was this sort of social vetting. As I described it, no one was more than one level removed. In some cases, I had known these people for a decade. That de-risked significantly the type of people that we brought on. That's not always possible if you're trying to find a co-founder, but I think it maybe on a longer time scale, it argues for building relationships and nurturing them over the long term with high quality people. Because if you ever start a company, it's nice to have that network.
And the trick with the recruiter is definitely underappreciated. I never saw or heard someone actually tapping into the wealth of experience of recruiters who know a lot of people, who saw a lot of people. They, even though they're not subject matter experts, they learn to see people for their qualities. So they might be a little bit wrong about the subject matter piece, but then if that person got hired by the top tier employer, then they definitely are good in terms of the technical skills. And since the recruiter can feel the personal side of things, yeah, that makes them a great source of potential co-founders.
One other heuristic that we use when evaluating candidates, not just for co-founders, but just generally, and Eric Scufzo, one of my co-founders, uses this expression all the time during the interview process, just asking the question of whether a candidate expands our convex hull as an organization. So if you imagine a sort of faceted balloon in space, does this candidate push out that balloon in some direction? And it doesn't always have to be like a hard technical skill. It could be a set of experiences or a perspective or something like that. And that's a way of thinking even about diversity in hiring, is that the way in which a person expands our convex hull may be that they bring this breadth of experience that none of us have, and we'll be thinking about problems differently and probably better. And so that convex hull expansion is a filter that we apply to candidates. So if it's like, yes, they're brilliant, but this other person does everything that they do and slightly better, then there's no expansion of the hull.
This is a very interesting and very visual model of what to look for.
I talk with my hands a lot, which again doesn't translate to this medium, but
Yeah, we should do it in a video at some point. That's for sure. We should let the listeners appreciate your
see my hands.
gestures.
Yeah.
Yeah, why not? As an entrepreneur, you build a company that builds the products. And how do you think about this? What kind of people, processes, and culture is needed for Graft to succeed?
People are at the center of it. And I think all of the culture and the processes are in service of those people, not just individually, but trying to amplify their collective effort. So, for example, parts of the culture are about ensuring alignment and collaboration because to amplify their collective effort, they all have to be pulling in the same direction. And if a little bit of work from one person enables another person to pull much harder, then that's a collaboration that they should do because then collectively we are pulling much harder than we would if we were just pulling individually. And so, at least from a process perspective, that's very much how we think about it. As we introduce processes when we believe that they will improve the velocity or quality or other sorts of kind of important outcome metrics for the business, but it's all in service of helping those people do their best work. Culture is partly prescriptive and partly descriptive. So, sometimes you'll like write down, like we have a culture doc that, was started way back when the company was just me and Maria. And we tried to articulate like what are the values that we've want to steal from other companies and like carry over into Graft, or ones that we don't think are kind of as important or relevant. And it evolves over time. So as you bring people into the organization, you might rethink what belongs in the culture doc. What is it actually like to work at the company versus what's aspirational, and that just evolves over time. But the intention of those values is to be a way for an individual to reflect on whether or not they are being effective in the organization by their behaviors. Bias for action is a good example of this. Thinking about a problem and wringing your hands about it or complaining to people or something, that doesn't bias for action, and that's always less effective than like writing a document articulating the problem and suggesting some solutions to try to rally people around to take an effort, or to just solve the problem yourself instead of just complaining about it. There's no snacks in the kitchen, so let me go and buy snacks. That bias for action means that as a whole organization we'll just be more effective because we're not sitting around waiting for someone else to do something.
The recipe is bring the best people and let them be most effective selves through processes and culture.
Yep. Accumulate extraordinary people around an inspiring vision and then support them in being maximally effective via processes and culture.
Now, when you're hiring new non founding members, you already talked about how the person should expand the balloon. Any other specific things you look for? And specifically when the candidate is not a fit?
So I think we're pretty sensitive to like cultural things. So, if a candidate is, rubbing a certain interviewer the wrong way or anything like that, we usually pick up on that pretty easily. We have, a few women co-founders, and, sometimes we'll interview a candidate and they're just like clearly not treating those interviewers with the same kind of respect that they were treating other interviews. And this will come out during the debrief where, all the male interviewers had one experience and the women had a different one. And, those sorts of things get pulled out pretty easily. One thing that we continue to look for, because we're still relatively small, is some evidence of a kind of entrepreneurial mindset. So certainly experience at a startup is an easy way to filter for that kind of thing. But even within a larger organization, is this the type of person who just waited for the organization to do something, or, again, complained about something, versus figured out how to marshal the resources and solve the problem and do the thing that is best for that organization, even if they're not handed everything on a silver platter? Like, do they have that kind of mindset? And that sometimes comes out in the interviews, sometimes it comes out in the references. But I think that mindset is super important at this early stage because we don't have a ton of supporting processes and people and infrastructure just yet.
And people often get lost when they join small startups with the expectation of that handholding and they don't get it.
Yep,
It's not only reduces their productivity, it also distracts everyone else. So it's a problem all around.
that's right.
Let's talk about you personally. You were initially on the academic track, working at MIT and Stanford. What led you to switch to the business world?
Yeah, it's a great question. So after my PhD at Stanford, I did a postdoc at Berkeley in the AMP lab, working with Jan Stojka. And I was there at the same time as, the Spark and later Databricks folks and a whole host of other really extraordinary people, almost all of whom started companies, I will note. And at the time I was, doing the faculty job search still. I still thought I wanted to be an academic. But the longer that I was living in the Bay Area, the less I wanted to live in particular other places around the country. Like I just became very geographically restricted. And my research kind of spanned two domains. It was kind of somewhere between math and ML and statistics and systems and data sort of things. And frankly, getting a faculty job at a top tier institution when you're not purely one field is harder. And so this combination of things meant that like I would partly by self-restricting and partly by virtue of the job market not being particularly amenable to my background or research, meant that there were like very few, it was very unlikely that I was going to get the faculty job that I was going to be excited about. And in parallel, the project that I was doing in the AMP lab, which was called Carrot, like a diamond, just met with a lot of sort of surprise popular success. So this was a mobile battery analytics app. It would tell you not just what's using up your battery, but why it's using up your battery and whether that's normal and what you can do about it. So much more nuanced, actionable diagnoses than what phones even today do. And so I thought I was going to have to pressure my friends to use this so I could get enough data to write a paper. But as it happened, I had a friend, Josh Constein, who was working at TechCrunch at the time. And I told him about the thing and he wrote an article about it. And within the first 24 hours after the article came out, we had 100,000 people using the app. That quickly ballooned to about 1 million in like a week. And so I spun out a company kind of based on that product. And, this through a series of events led us to Splunk and then, at Slack, which then of course led to Graft. And that was kind of how I veered out of it. It was sort of disillusionment by the faculty search combined with this surprise commercial success of a research project. And just generally then over the next decade or so at Splunk and Slack, kind of seeing where industry really is as far as AI goes and seeing just so much opportunity to bring it to the rest of the world.
You literally got sucked into the business world by virtue of building that app.
Yeah, I will say also, once I, spent a year or two working at Splunk, with getting a real paycheck for the first time in my life, it's also really hard to go back to not making a regular paycheck, although I'm kind of doing that now. But, it definitely doesn't make academia feel especially appealing. I think, though, in AI and systems in particular, the best research is coming out of industry anyway. And so as that became increasingly the focus of the work that I was doing, even if I wanted to do research, academia may not be the right place for that anymore.
That's very true. Academia and industry, we can say partner in research, but the leading role is not always academia. And starting Kuro Labs and going through that experience, how did it maybe instructed how you approach building Graft today?
So I would say at kind of every stage of my career, I learned things that I am now applying at Graft. So, I could look back even before Kuro Labs, looking at my experience in academia, that taught me how to fail over and over again without viewing it as a personal failing. Which, if you've ever done an early stage startup, like it can feel like failure. Hey, I built this really cool thing. Would you buy it? No. Okay, I built this slightly different, really cool thing. Would you buy it? But you don't take that personally. And folks who have come out of an academic background tend to be more resilient to that sort of thing. But it also taught me how to work hard on a hard problem and then find a novel solution to it. And I think finding a novel solution to a problem, even one that has a problem that is well known and well understood, that is what building a startup is about as well. For Kuro Labs, some of the lessons were positive and some were negative. So like one of the negative lessons is I personally don't want to build a B2C business. Like that's super hard. It's just not my jam. Consumers are extremely fickle. But one of the other positive lessons was the importance of having extraordinary co-founders. So, we've talked about how that's manifested at Graft. And at Kuro Labs, I co-founded it with Jacob Leverich, who is now a co-founder at a company called Observe and was another cohort in the Stanford Ph.D. But he's amazing. And again, I couldn't imagine founding a company with people who I don't admire. And that was an important lesson. It was not a sort of short-term, you don't like grab someone who's like a short-term pragmatic fit for the part of the business you don't want to deal with. I think that's, for me at least, that's not the way that I think about that relationship at all. Then going on to Splunk, it taught me the value of a technical moat. People would talk about, I'm going to build my own Splunk or whatever. And then they realize that timestamps are hard and other things, and they come back and buy more Splunk, but also the value of having a strong enterprise sales organization. And then sort of a counterpoint to that at Slack, I kind of learned the value of product-led growth. They were much more product-led growth rather than enterprise sales. So getting to see kind of extreme versions of each of those two, both the strengths and weaknesses of them, have informed our go-to-market strategy at Graft. And also I'll say that Slack had a really healthy culture, I think, in general. And so we've tried to steal what we think are the best parts of that for Graft.
It does sound like you had a very good mix of experience.
I've been extremely fortunate to have a diversity of experiences and to work with really amazing people in my career. Been very lucky.
And to your other point, early stage startups do train you to fail a lot. That's underappreciated by many starting their first companies. But that's a very important point to realize that all those failures are temporary. You will come out on the other end.
That's a really good point. And maybe even failure is the wrong word. Like viewing it less as I tried a thing and I failed, and more like I have gone through one iteration and then I will go through another and I will go through another. And each iteration I'm learning something. So it's not a failure. It is forward progress as long as I think about it the right way.
Exactly. Yeah, we're totally fine with the fact that we will fail first time we cook a very complex dish, for example. We don't expect ourselves to nail it from the first attempt. But for some reason, when we think about much more complex thing, it's building a company, we expect, we're going to succeed from the first go.
Yeah. With cooking, you even have a recipe. Someone told you how to do it, and you still might not succeed the first time. Starting a company, you definitely don't get that. No.
It's 5 orders of magnitude simpler thing, and you still manage to fail in cooking. And for a whole other complexity level, expecting it to work from the first time is detrimental to your progress. You should expect to fail multiple times before you achieve first strong results. Okay, turning to the future now. How do you think about long-term goals for Graft?
So you've probably heard the expression, software is eating the world.
Yep.
AI is now starting to eat software. And like any transformative technology, the companies that adopt it effectively are going to be more successful, which will give them more money to invest in those technologies. And you end up with a gap that will widen between the companies who have adopted AI successfully and are addressing a host of business needs with that technology and the companies that are left behind. I don't want to live in a world where there are like 5 companies, and those are the ones that are, making all the money and building all the cool stuff and accumulating all of the talent. And I don't want to live in that world for a lot of reasons, but one of which is that a lot of the companies in that 99% that would otherwise be largely left behind are doing work that I care a lot about. So included in that 99% are not only a bunch of products that I use, but also basically every nonprofit and a bunch of other organizations that are doing really good work to make the world a better place. And if they can accomplish their missions more effectively by leveraging these AI technologies, then the world that I live in, my kids live in, and friends and family and so on, like it's just better. It's a better world. And so, I view this not just as a business opportunity, but it's also an opportunity to support all of these organizations doing amazing work to be more effective. And so long term, I'm hoping that we capture the 99%. I'm hoping that almost every organization in the world is able to leverage these modern AI technologies and that they're not left behind and that they're more effective at their missions and do better work.
That's a vision to look forward to. And for the last question, let's talk about the evolution of AI in general. What excites and concerns you most there?
Like any technology, I think AI can be used for good or evil. And some of the technologies that I find most exciting are also the ones that worry me the most. So, for example, generative AI, right? Like the kind that lets me take a video, edit the text of the transcript, and have it generate a new video in which it appears that the speaker is reciting the edited text instead of what they actually said. That's pretty terrifying. On the other hand, though, I think we'll see a boom of creativity and art, and it will be accessible to populations like me who are less artistically inclined, but who would take joy out of being creative. I think that's a wonderful thing. And I think we're going to see a proliferation of really positive, awe-inspiring use cases for that generative AI. And I think the thing to recognize is that the technology is going to move forward no matter what we do. But what I hope is that as a society, we figure out how to either regulate or mitigate or protect ourselves against the negative effects of those technologies. And I believe we will be able to do that, despite, ironically, a mountain of evidence to the contrary.
We managed to adopt and co-live with all the previous waves of technologies. Hopefully, we'll be able to get on top of this one as well. Specifically on your point of video generation and video editing, I 100% agree with you. It looks to me that we learned not to trust random text that we see on the internet. We see some post somewhere, we don't necessarily trust it. We definitely trace it back to the source, where that post came from, and if we trust the source or not. This is the only way for us to assure that it's valid.
Yeah.
With video, it's not the case. We see any random video on the social network and we're like, oh, if it's on video, I saw the evidence. I saw it with my own eyes. But I think in a year or two, thanks to those generative models, we will start treating video maybe just as we treat text these days. So we will just don't trust any video we see until we trace it back to the source and make sure that it's a valid thing.
Maybe. And I think the challenge, though, is if that is how we react to it, and we just sort of stop trusting a video, there's sort of the inverse situation where it's important, like the video is real, and it's important that we believe it because it is evidence of something that as a society we need to act on. If we dismiss video evidence, what evidence are we going to rely on exactly? People don't trust authority, or some people don't trust authority. If they don't trust text or video or any sort of other digital evidence, where is the source of truth then? Anyway, I am a technology optimist, so I think we will find ways to address and mitigate a lot of these issues. But that is the sort of the way in which I am concerned by some of these technologies.
This is a very good point, actually. We will need some sort of authentication for the real videos that everyone can trust. That's another challenge for technology. Basically, this is how it goes. We invent our own problems and then we work hard to invent ways to fix those problems with another wave of technology. Maybe blockchain will help us there.
I was just going to say, it's like I feel like we're veering into that. If only we had some sort of immutable ledger with cryptographically provable properties. And
yeah, wouldn't it be great?
Well, we're not a Web3 company just yet, so we'll maybe we'll revisit this when people are generating things with Graft and don't trust what they're seeing.
Right. Okay, Adam, thank you for joining me today. It was a pleasure to talk to you.
Thanks for having me, Artem. This was a lot of fun.
Thank you for listening. You can learn more about Graft and schedule a demo of the platform on their website. You can follow Adam on LinkedIn, and you can reach him with any questions about Graft at adam@graft.com. The links will be in the show notes.